Okay, so 4.4 component characteristics. I'm going to look at some more IV curves. So last lesson we looked at the one that was on resistors and for resistors only. So let me just show you that one again, just so that we've got some understanding about what's going on. So an IV curve is measuring how does the current change when the voltage changes. Okay, and we said that if you've got something special called a resistor, then it is a nice straight line, okay, and the gradient equals 1 over the resistance, and that was because y divided by x is your gradient, which is current divided by voltage, and Ohm's law, we said last lesson, was resistance equals voltage divided by current. Okay, so that means that the gradient is 1 over the resistance. So that means that if I've got a gradient that is slightly lower, this means that this one is a higher resistance. And if I've got a gradient that is steeper, that means that is a lower resistance. And that's a little bit confusing, because what we're saying is that the gradient is 1 over the resistance, so the bigger the gradient, you're doing 1 divided by a big number, is going to give you a smaller number, and 1 divided by a small number is going to give you a bigger number. Okay, so let's have a look at some other components. Actually, let's add some numbers to that. Let's do some numbers first, just to make sure that everyone's happy that this one's got a higher resistance than this one. So let's say that this gradient here is a gradient of 5. This first one for the red one, so grad equals 5. And we know that gradient equals 1 over r. So that means that's 1, and that means that r equals 1 divided by 5, which is 0.2 ohms. Let's say that the green one has a grad of 10, so that means that R equals 1 over 10, so that equals 0.1 ohms. And let's say that the blue one has a grad of 20, which means that R equals 1 over 20, which equals 0.05 ohms. Okay, so you can see that the steeper it's getting, the lower the resistance is, because you're dividing by a bigger number. Okay, and that's all to do with the fact that resistance is voltage divided by current, but on an IV curve you do the I on the y-axis and the V on this one, and I'll show you why you do the IV curve that way around now. So let's take a look at something that doesn't obey Ohm's law, and let's have a look at a light bulb. And in particular a filament light bulb. And what's special about a filament light bulb is that as you've got your light bulb, it's got a wire on the inside, and when you increase the voltage, it increases the temperature. So what effect does that have? So that's the reason, that's the way that these light bulbs work. When they get hot, they start to glow and they emit light, okay? Because they get white hot. But what effect does that have on the amount of current and the voltage that's going through them? So let's have a look. So let's have a think about this. If we say that the harder it is for the electricity to go through, the higher the resistance is going to be. And when you think about your atoms in a wire, when they start to vibrate, so when the atoms in the wire start to vibrate, because they're getting hotter, they're moving around more. So they're just vibrating, they're just jiggling like this. And the more they jiggle, the harder it is for the electrons to go through here, because they keep interfering with these atoms because they're moving, and it's really annoying. They keep getting in the way because they're jiggling around so much. So the more they're moving, the harder it is for the electrons. So more thermal energy equals more vibrations equals more difficult for electrons to flow. Okay, so that's what we're saying. We're saying it's got more thermal energy, it means more vibrations of the atoms, which makes it more difficult for the electrons to flow through my circuit. If you look at the next bit, how does that show itself on the IV curve? Well, if I put my curve here, if it's getting more difficult, then I would expect my gradient to be getting less steep. So for my light bulb, as it gets hotter, the gradient is going to get less steep. So you get a curve like that. And this side here is positive, this one is positive, this one is negative, and this one is negative. Now, a light bulb doesn't care whether the current's going one way or the other, it doesn't matter. So what you get in terms of positive and negative differences, you just get a reflection in the y-axis, where if that is 10 amps, then this one here will also be 10. It's a complete reflection. Okay, so remember that's current, and that's voltage, and this is negative voltage, and this is negative current. But what you get is you just get, first bit to remember is, as it gets hotter, the resistance increases, so we would expect the voltage to make less of a difference on the current, because it's harder and harder to make the electrons flow through the circuit, so it tails off to a limiting factor. Okay, and that makes sense from the fact that the higher the resistance, the lower the gradient, which we worked out here. So harder and harder, lower and lower, until it's horizontal, and that's when the resistance is infinite.